attended the Introduction to Hedera workshop and the opening ceremony, you probably know the drill by now, right? So please greet us and let us know where you're dialing in from. Yep. Okay, it helps make this session feel a bit more personal as we say hi and connect with one another. Yeah, so please go ahead and feel free to type your greetings in the chat. Okay. Yes. So I also just want to share it that tomorrow is our first AMA session, July 24th at 10 a.m. to 11 a.m. Eastern Time. So all our mentors will be attending this AMA session, aka Ask Mentors Anything, and we will have a breakout session so you can have a time to talk directly to the mentors based on your chosen track. So the information will be is now shared actually on this live session details, and you can also scan the QR code you can see from my screen right now, so you can browse to the calendar and please subscribe to it. Yeah. Okay, now I know that some of you must be in the middle of refining or polishing your builds or preparing to submit, maybe. Then I personally believe that attending this workshop entitled Building AI Agents on Hedera will be a very helpful session for everyone here. Well, it's not just because this session will be a highly informative one, it's also being led by our very own mentors from Hedera Origins Hackathon. So, of course, these speakers bring deep expertise and hands on experience and makes this session a unique opportunity to learn directly from them. So, yes, let me introduce one of our amazing speakers, someone many of you may already know. He's Hedera's very own developer relations engineer who made his mark by winning not just one, but two Hedera hackathons before joining the team. Yeah, he truly is a talented and driven individual who walked the same path as you are now. So please welcome Jake Hall.
Hey everyone.
Right. Yep. And of course, I'm also excited to share with you that together with him is Hedera's developer advocate, focusing on the AI and agents track. So if you're on the track in this hackathon, she is your dedicated mentor as well. She brings a wide range of expertise from cryptographic system to platform development to programming languages and beyond. There's more in the list. So it's no surprise considering she started her career in mathematics and computer education. Amazing. So there's no doubt that those strong foundations have powered everything she does today. Let us welcome Lindsay Walker.
Hey, it's great to be here. This is my first hackathon with Hedera, so I'm excited to be here.
Of course. Yep. So passing the ball to Lindsay now.
Hi. All right. So today, are we sharing my screen? Oh, there we go. All right. So today we're just going to talk about building AI agents on Hedera. We're kind of developing what is known as a new studio within the Hedera ecosystem, where we're testing out some new proofs of concepts. We're building more tools for developers, and today we're going to go over some of the latest and greatest tools that we've built. But first, I'm going to give you a little bit of background about what these things are and why we think they're important. So as we said, there's Jake Hall, who is our mentor, and myself. I'll skip over that though, because they did our introductions. So first, we're going to talk about what are AI agents and what is the model context protocol, if you don't know already. Although if you've been keeping up in the space, there's a lot of really exciting updates coming about this every week. It's something new is being developed, but we'll talk about how we got here and what these things are. Jake is going to talk a little bit about agent frameworks. And then I'm going to talk about, well, how do we blend together AI agents and blockchain functionality? And then specifically, how do you implement AI agents on Hedera? And then we will end the session with Jake giving you some how-to demos of our AI agent SDK created by Hedera. So let's talk about what are agents. So what are the agents and why are they so important? And then how does the model context protocol fit into all of this? So agents is not a new word. It's not a new thing in society. The idea of an agent has been around for a while. Originally, they were just people who have a helpful relationship with us. They help us accomplish tasks and goals. Think travel agent, think customer service agents. They're people that help us, that act on our behalf to help us get certain things done. Agents have been around a really long time in computer science as well. Usually these were typically, before we had AI agents, agents were sort of rule-based actors. They had really static programming rules. You might create an agent that is, if you're doing a traffic simulation, you might create an agent that is a car, and that car moves around according to certain rules in an environment. Before we had artificial intelligence, they usually interacted in a very static environment according to rules. And we'd use a bunch of different agents with different rules to model behavior, and they'd act in a more complex system. Now that we have AI agents, it's not as static. We have these AI agents working in more complex systems, except these agents are dynamic, they're flexible, they're intelligent. They can reason through complex multi-step tasks, they utilize memory, they can even learn. And they have the ability to operate autonomously in not just one environment, but now with MCP, we're giving them access to many different systems. So my hot take is that AI agents are the new user interface. Instead of having to go to a website and click through things to make a bank transfer or to purchase something, we're going to have AI agents that can act with high autonomy, learn, and perform multi-step actions. They can integrate outside tools. So in my bank, I'm going to transfer money. I'm going to go to my wallet. I'm going to transfer funds and purchase something. We're going to have agents that are going to be simply given a human sort of command, and they're going to be able to act on your behalf. Agentic workflows are multiple steps. They can combine inference models such as LLMs and tools such as an MCP server to access a data source or get into a platform. And it enables them to perform much more complex tasks than what we could previously do with an agent. So 81% of organizations, according to the research I did, are either exploring AI agents, it's about 50%, and about 20 to 30% of them are piloting these AI agents as an interface. So what is Model Context Protocol? It's an open protocol, and it's a way to standardize interactions between AI models and systems. In other words, there are rules, so when you have an AI model and you want it to access your system and act on it, you need to follow the standards outlined by MCP. It allows developers and users to build plug-and-play connectors that work across models and platforms. MCP is enabling the building of agentic workflows. So I think the next move, the next thing that's going to happen is we're going to have agent-centric design when people are building things. Instead of using API standards, we're going to use MCP standards to make sure the software that we're building can connect to agents. We're going to want to make sure when you're building a platform that you're using MCP standards and things like prompt templates. We want agents to be able to access fresh data, trigger external actions, incorporate contextual information. So think about, I'm working in my IDE, my agent can see what's happening with all my files and what updates I'm making. And then we wanted to use tools and services. So the paradigm for how are we building software is going to change, because instead of humans accessing it, it's going to become more and more agents accessing it. So what are some of the things that you could do with this? DeFi automation, like I talked about before. Instead of having to struggle with multiple wallets to try to access your accounts, you can just tell your AI agent to make transfers for you and get the tokens that you need. You can have automated assistants help you with scheduling your day or carrying out parts of your businesses. You can automate services and support for your customers. So there's all sorts of types of things that you can do with it. I'm going to talk a little bit later about some specific examples of it. And I'm going to hand it off to Jake to talk a little bit about agent frameworks.
Amazing. Yeah. So thanks a lot, Lindsay, for sort of giving that overview as to what an agent is, both within the context of AI and outside of it. Now we're just going to have a very quick dive into how can you actually build them. And we're going to be building on that in the next 3 or 4 sections within the slide before finally doing in real life demos. So basically what I'm going to be showing here in about 20 minutes, we'll also be doing, seeing it in the code. So if we go to the next slide, but before we get into AI agent frameworks, there's the one way to create AI agents is by using the API tool calling facilities directly. So here I've got a snippet from OpenAI, and this is one way to create AI agents not using the framework approach. You can think of this as using vanilla JavaScript versus using something like React, where React is obviously the framework, it comes with the whole ecosystem, etc. But in order to do it the sort of the bare metal approach, you have to pass in your tool to your OpenAI client. This is very similar if you want to be using things like Anthropic. And as you can see, you sort of specify the schema. You've got to do these pretty extensive objects. And then once you've sort of created that tool, you pass that into your client. And then in the next slide, in the next section, we see that after you've created your client, which knows it has these tools, when you ask it a question, it will come back with the function to call and with the argument. So again, it's very, very manual, this approach. And we're going to be explaining why you want to use a framework and not this approach afterwards. But as you can see, it tells us the AI response is, okay, use this function with these arguments. And you then need to manually put it into call that actual function code by taking the arguments from that particular response from the AI. And then after that, you need to go and take the result from the function call, pass it back to the AI agent, who then uses that message and comes back with a human answer to the user. So as you can see, it's quite, there's a lot of boilerplate which is needed. And this is really the reason why you would want to use an AI agent framework. So if we head over to the next slide now, just see a few more reasons as to why we'd want to use it. As you can see, AI agents, we'll see this at the end, but there's way less boilerplate code. So the developer experience is much nicer. You don't have to go through that sort of extensive creation of highly complex objects and then taking the AI's response in terms of what function should I call, actually then evaluating that and then going back to the AI. All of that's abstracted away. You can also plug into wider ecosystems. So we'll cover things like LangChain. LangChain is a mechanism, it's a framework for building AI agent frameworks. Let's just keep on so you'll previous slide. Keep on this one, yeah. So LangChain, for example, you can integrate with the wider providers that LangChain has. Lots of stuff on vector databases, lots of stuff on document loading pipelines. You can also build out multi-agent frameworks much more easily. So again, most of the leading frameworks, the ones which we'll cover in the next slide, but we'll stay on this one just for the time being. Most of the leading frameworks, they have really easy ways to orchestrate not just one agent, but 3 or 4 agents, where you can do things like handoffs, where, okay, you've got this one orchestration agent, and depending on the task at hand, it knows, okay, I've got this buddy of mine over here who I can hand over to, who will then run in his own autonomous cycle. Memory, very important, short-term memory and long-term memory for AI agents. So within the framework context, all of this is given to you outside of the box. And many AI agent frameworks have tracing metrics. So for example, when you're building with the OpenAI Agents SDK, all of your inference patterns and all of your responses are all on you can see it all on the platform, on the OpenAI platform, OpenAI dashboard, essentially. So yeah, let's have a look at the next slide then. And this is just a snapshot as to some of the most popular frameworks at the moment. So we've got LangGraph. LangGraph is, kind of think of it as a subsidiary of LangChain. LangGraph is probably the most popular way to build AI agents in Python. They also have a JavaScript SDK. And what's really powerful about LangGraph and the wider LangChain ecosystem is how effective it is at integrating into many different potential AI providers, database providers, LLMs, basically anything that you need to build a robust production grade application no matter whether you want to use Anthropic or OpenAI or an open source model hosted, no matter if you want to use ChromaDB for a vector database or Pinecone or Amazon's vector, whatever, LangChain will have a connector for it. And what that means is you can easily, you can run some experiments locally using open source tools. And then as you promote it to production, you can start using something which is a bit more robust without having to rewrite your whole application. The Cell AI SDK is another really popular AI agent framework. It's only written in TypeScript. And as you'd probably expect with the Cell, it's very, very well integrated with Next.js, which is a front-end framework. Generally speaking, if you're building a full stack application where you want to have a really powerful chat user interface and you're using a web framework like Next.js or Nuxt for Vue or SvelteKit, it might be worth having a look at the Cell AI SDK, because not only has it got the AI agent framework where you can create your own custom tools quite easily, you can also, it also provides and exports a lot of very user-friendly hooks, which are needed to provide a nice user experience to your end user who's going to be interfacing with your application via a chatbot. OpenAI AgentKit, this is also available in Python and JavaScript. Where OpenAI, where this one is quite strong, where this one's quite a good option is if you are heavily leveraging the OpenAI ecosystem. OpenAI AgentKit would be quite a good shout. As I mentioned earlier, on that point of frameworks giving you tracing and auditability, by using OpenAI Agents SDK, it automatically shows you the whole reasoning steps and every single sort of prompt and response and all of the stuff that happens in between. That's easily viewed on the OpenAI dashboard. And finally, MCP. Now, this is technically a protocol. I have included it within the context of frameworks because, like others, it essentially enables a very easy way for an AI agent to interact with tools. And everything that you've seen on here, bar OpenAI AgentKit, Hedera has tools for, meaning you can use LangGraph or the Cell AI SDK, and you can create AI agents using those frameworks. And inside of those frameworks, you can leverage Hedera compatible tools. So you can have your own custom AI agent, which maybe searches the internet or does Stripe calls because there's a Stripe toolkit. And then it can also interact with Hedera. You can also create tokens, transfer tokens. We're going to be continuously building out the functionality. Likewise on MCP, we've got an MCP server, which means you can connect any MCP client to our Hedera AgentKit MCP server and also start interacting with the Hedera network just from your local machine. So we're going to be covering all of this. Definitely stay towards the end because LangChain, the Cell, MCP, we're going to be doing demos of all three of them. OpenAI AgentKit will probably be in the SDK pretty shortly.
Awesome. Thanks so much. All right. And then I'm going to change gears a little bit and talk a little bit about, okay, AI agents and blockchain. How are we building useful agents specifically using blockchain technology? You can always shoehorn blockchain into it. You know, you can put whatever data you want on blockchain. You can create interactions on blockchain. However, when you're building your application for this hackathon, think about what actual utility does blockchain provide, right? We can put data on blockchain, but is there a reason for it? Usually you want to use blockchain if you need a tamper-proof, an immutable, auditable record of agent transactions. And, you know, the Hedera blockchain is great because it has fair ordering, high throughput, and there's no delay with the Hedera. And it's not, well, technically it's not blockchain, it's a distributed ledger, but we have no delay waiting for finality. So think about the use case for it. Do we need a public record of these agent transactions? There's lots of good reasons for it. There's also good examples of when you don't want to put your record of agent transactions on the blockchain. So when building your application, think about that. Of course, super easy, quick international payment rails. If you want to build agents that can autonomously execute things and even do things like make purchases for you, make payments, blockchain's a great thing to use for that. And then it obviously adds in the advantage of smart contract programmability to set rules for those payments. And smart contracts are also great because you can set some kinds of limits and guardrails. So there's lots of features of Hedera, like using multiple wallets or giving allowances that allow you to set limits and guardrails on your agents to do that. And of course, Hedera has smart contracts, but we have a lot of native services available. Our consensus service, our token service, and obviously our smart contract service have a lot of built-in functionality. So take a minute to go and look at the docs and say, hey, what can I build really easily into my agent to pair the ledger capabilities with AI? So take a look at the native token, consensus, and smart contract services in our docs. Here's some ideas. There's a lot of things that I think haven't been done yet, building with agents and building on Hedera. We can make an NFT marketplaces. We got a lot of those. We got social apps already. Let's think a little bit wider. So I really like this quote. The blockchain does one thing. It replaces third-party trust. So having to trust a bank, having to trust a government, having to trust somebody taking care of your contracts with mathematical proof that something happened. What can we do with this? Here's some ideas. Don't take me at my word, but just some suggestions. We could build decentralized data oracles and integrity verification. Create an agent that can clean, aggregate, validate data that's off-chain, and then feed it into smart contracts in a nice structured way. Use the machine learning to detect anomalies, manipulation. So putting it on blockchain means we have an assurance of provenance and auditability. We could create a marketplace of AI-verified data sets. Another idea, autonomous supply chain agents. Supply chains are complex. There's a lot going on there from a lot of different parties. Monitor and optimize logistics in real time. We have immutable records of that. And even maybe use the agents to detect inefficiencies or fraud. We could build a SaaS platform where users track and pay for inventory along the supply chain. We could have tokenized AI agents. AI agents are really useful. There's a lot of them being built. How do we access them? How do we give them to the general public so they can pay for them? Use a decentralized ledger and create economic rewards for certain behavior, and use smart contract programmability, build a platform for purchasing and using AI agent services. Another idea, these are more of sort of our enterprise type use cases. I could definitely see these being really useful to some larger customers and clients if they're looking to build these in. Predictive maintenance and IoT security. There's tons of IoT devices in large campuses. We have like HVAC, doors, lights, whatever there is. There's a lot of sensors there. There's a lot of communication going on there. Build some agents to take all of this data, record communication, sensor readings, maintenance, and there's a lot of uses for these. So if we had all that data and we had it in a usable way, you could help with insurance claims, warranties, legal compliance, security compliance. Build an enterprise tool for a factory that can monitor and predict security issues and equipment failure. Another idea, healthcare data integrity and real-time analysis. Again, there's so many pieces of data out there with medical devices, like wearables, hospital equipment. Store this immutably on a permission blockchain. Permission is key here because this is legally protected data, private data that we don't want to have out there. But if we had this in a blockchain, we'd have a good source of data for AI agents to analyze incoming data, make predictions. From even if you have 2 or 3 different devices, we can combine those together for early signs of risk or adverse events. So you could build a performance and audit dashboard for patients using devices used by hospitals and healthcare providers. Again, these are very complex ideas, but just wanted to nudge you in the right direction of what are some more creative, bigger picture ideas of what we can do with the blockchain. All right, so I'm going to do a quick high-level overview of what's in the AI Agent Kit, and then I'll pass it off to Jake for a demo. So GitHub repo right here. Hedera dev is the org. Hedera-agent-kit is our GitHub repo. There's a few different parts to this that we have in the README that you can just get started with quickly. So if you just want to quickly kick the tires, use an npm install. Do our quick start hello Hedera agent kit. You do npm install, set up a quick index.js, which we have an example of, get your environment variables, and there you go. You have your boilerplate dApp up and running. You can start building off of that. We also have a few examples that we've set up using LangChain and different conversational agents. So there are two types of demos of conversational agents. We also have a human in the loop agent, which is a little bit of a different workflow. And then there's the MCP server. And I believe, is the Vercel one in there already too, Jake? All right. We also have a Vercel demo, but I didn't make a slide showing you where it is yet. So yeah, if you want to take a look at what we have, here's the QR code. The first thing you'll see is sort of like the 60-second quick start. As you can see, npm install, init it, touch it, and then we have a quick little demo you can use as a boilerplate. There's two different structured chat agents that are in autonomous mode. This means that you give it a command, it's going to execute it automatically. It's really useful for certain things, but also have caution, because if you build it on mainnet, they're gonna go wild and they're gonna execute those transactions. We have it more of a human in the loop agent, and this is a little bit trickier. You need to fudge around with it a little bit to get it to do exactly what you want. But the point of this one is, before it executes anything or does anything or creates an NFT, it's going to come to you and say, is this what you want? And you'll give it the go ahead to do that. And then we have the MCP server. This just shows you how you can use the MCP server to connect to Hedera agents and build it into your application. So now that we know what we have, plus the Vercel functionality, to go over it, the tools that we have available now are the Hedera tools. We have account, consensus, and token service. So you can transfer HBAR, create a topic. That's how you sort of put messages online that other people can subscribe to, look at, and even contribute to. We can create fungible and non-fungible tokens. So these are just some basic functionality that's there now. The query tools we have available is you can get information about a given account by the account ID, the token balance, HBAR balance, and your topic messages. And then there's LangChain and MCP and Vercel on there. It is limited right now. We're working on building that out. There should be links within the README to submit an issue. Please, please, please submit an issue. If there's functionality that we want to know what it is. And so we can get to building that into it, because there's a lot more that you can do with Hedera. And I'm going to pass it over to Jake, who's going to take over and do a bit of a demo of these things.
Amazing. There we go. So yeah, I mean, as Lindsay mentioned earlier, head over to the GitHub repo. You can see it over here. This is the URL, GitHub, and then just in the Hedera dev organization, Hedera AgentKit. I mean, if you type up Hedera AgentKit GitHub, it will probably show up. It should show up as the first result. And obviously, once you've cloned it, well, you can start then interacting with the out-of-the-box demos, or you don't need to clone it. You can just install it on NPM. The README is all over here. Follow the instructions which Lindsay just shared, or just go straight to the README. You can install it. Or if you want to have a bit more of a guided experience, you can run some of the example demos that we have in this TypeScript/examples folder. So what I'm going to be going through, I'll be going through the LangChain framework, which I was talking about earlier. I'll be going through the AI Vercel SDK framework. And then after that, we'll also cover Model Context Protocol, or MCP. And we'll be very, very thorough and sort of cover everything. Now is also a good time, by the way, so the guys and girls watching this, if you have any questions, just put them in the chat. Whether it's on YouTube or LinkedIn or X, we'll find it. We'll be able to answer them. So yeah, now's a really good time to do it. And I see we've got the vibe coding music on. I love it. We've got the tunes on. If you don't know what this song is, you need to be joining Hashgraph Hustlers, which is a weekly stream that myself and one of my colleagues in the Hedera ecosystem does. Every Friday we do Hashgraph Hustlers, and we do lots of vibe coding. We do stuff like this. But anyway, let's get back to the main point. Shout out to Luis, who's backstage, who put that on. And yeah, let's check it out. So the first thing that we'll look at is the LangChain demo, and we've got a few different demos in here. The ones that we'll be running today is this tool calling agent, and then also we'll experiment with the return bytes agent. And the key difference between the two of them is that autonomous agent, it executes the transaction. It has its own private key. It's got its own private key and it executes it without asking for any permission. The return bytes agent is very good for human in the loop instances where maybe you want a user to use their Hashpack wallet or their Kabila wallet or their MetaMask wallet, technically not only Kabila Hashpack actually. You want to use it for their, you want them to take the transaction which is generated by the AI and then execute that using their wallet or some other human in the loop experience. And if we have a look at the code, the key difference is very minimal. It's that for the Hedera, for the AgentKit where we want to use the autonomous mode, we just pass in this mode autonomous. That's all that we need to do. Whereas on the return bytes example, you'll see that actually on the mode, we have, rather than passing in autonomous, we have return bytes, meaning whenever you generate the transaction, give me the transaction byte so I can sign it elsewhere. And we also need to specify the account ID, which would be the account ID that actually signs and executes it for the network. So the reason for that is because this is a bit of a technical point, but whenever you want to create a Hedera transaction using this SDK, you need to create a transaction ID. And that's created before the transaction is submitted. So part of that transaction ID includes the account which is going to execute and pay for that fee. Because we want to execute and pay for the transaction using the human, we need to pass in the human's account ID. Now, in this demo, you'll see that we're not using Wallet Connect. We're just doing a demo example where we're signing it elsewhere, but you can technically drag and drop this and implement it into your Next.js application or your web application. We also have a Next.js demo, which we can share. That's also found on the Hedera dev repo. But let's have a look at this tool calling agent. So again, I'll quickly run through what we're doing. We're installing the dependencies, importing the dependencies from the Hedera AgentKit. In this case, we mainly need to set up the Hedera LangChain toolkit. We're setting our client. So as you can see over here, we're taking the Hedera client, which takes a private key and an account ID. We're specifying which LLM we want to use. That's using the LangChain framework. There are two ways that you can set up tools and configure tools for the toolkit. The first one is you can manually select which one you want, like you can see over here. Or if you pass in an empty array, then actually if you pass in an empty array, then you see it actually will automatically load everything in. But best practice would be to only load in what you need, because it then reduces the risk of hallucination. Doing some other boilerplate stuff, setting up the chat prompt template, creating our agent with LangChain, and then over here we've got our CLI chatbot where essentially we can actually run it and start interacting with it. So let's do that now. Let's go over to our terminal, and I'm in the LangChain folder. I've already got my environment variables set up, and we can just do npm run LangChain tool calling agent. So this is going to be executing this particular TypeScript file. And as you can see, we now have a CLI chatbot where we can start speaking to an AI agent. So I've already got my private keys. I've already got my OpenAI keys set up, but we can say, hey, and then let's double check what tools I have in here. So we said we've got create topic. Yeah, let's do this. Let's say create a fungible token. Create a fungible token called Hello Future Origins. This is the name of the hackathon. If you haven't figured it out already, definitely sign up. I think there's a QR code in the top right where you can sign up. So let's create a fungible token called Hello Future Origins. The symbol will be HFO, and set an initial supply of 10,000. And then what we can do is I can go to get another account and I can say, then airdrop 10 of these tokens to this particular account ID. And because we've configured the AI agent using LangChain, which is a very robust AI agent framework, this will actually be able to, it's able to formulate multiple steps in one, in sort of one prompt. So it's able to go, okay, first task that I need to do is I need to create the token. So as you can see, we've created this token over here, Hello Future Origins. And then it says that it's airdropped 10 of them to the account. So we can check on Hashscan that this has happened over here. We can check on Hashscan that this account has actually received these tokens. And as you can see, it has. So it's received 10 HFO. And we can see, if we look into the create transaction, that it was created just 1 minute ago by the AI agent. So it's pretty cool. Obviously, this could be whatever you want, really. You can also, as I mentioned, tap into the existing LangChain ecosystem, and you can use other LangChain tools, which would be totally compatible because we're just using the LangChain framework over here. So it's very interoperable with other tools that other ecosystems, Web 2 or Web 3 may provide. Now, let's have a look at the return bytes tool. So this is, again, it's another example script that we have. And the key difference is, as mentioned earlier, we're now passing it with agent mode return byte. And what that means is technically we don't even need to actually set the operator over here. So we could technically delete this because we're using human in the loop. We don't need to have the AI agents have their own private key. We just want the AI agent to go, okay, the intent of the user is to create a token with X, Y, and Z parameters. Let's create the transaction for that. We build the transaction, and then we convert it into bytes for the user to then sign. So down here, we can see that we're invoking the AI agent with the user input. And if we find that the agent response contains bytes, what we're then doing is we're taking those bytes and we're executing it. This isn't really what you'd be doing in the context of creating a wallet connect integration. Obviously, it'd be slightly different. The way that you'd want to do it is you'd want to have the server side, the agent living on the server side, and then transferring the transaction bytes, maybe in response to an API call. But of course, this is just for demo purposes, and you can still extract the bytes and then execute it with a separate client. If you are thinking of doing a human in the loop flow, I'd highly recommend you join the Discord channel. So that's, you can find that just online, Hedera Discord or hedera.com/Discord. And by joining the Discord channel, you'll be able to speak to people like myself and Lindsay, who'll be able to guide you through actually creating these applications which maximize the usage of this AI agent kit. But let's go through a quick demo using the human in the loop flow. So again, we can just run npm run LangChain, and then we've got a return bytes tool calling agent. And if we do something simple like transfer 5H bar to this random account, and we click enter, we'll see that it's, I think I know what's wrong here. From string ECGit. Okay, hang on. Yeah, I'm gonna do it. So, right, I shouldn't have. I see. Right. So I removed this human in the loop client. That's what's actually signing it down here. The point I was making earlier, that the agent client doesn't need it, that was already the case. So as you can see, the agent client is what we're passing into this Hedera LangChain toolkit. This agent client doesn't need its own private key. Obviously, the human in the loop, they do, of course, need their private key. So I shouldn't have deleted that. Let's go back to the script and we'll run it again. And but that was just my mistake. So now if we use the demo again, we go transfer 5H bar to 0.0.800. We'll see that it will generate the transaction. And even in the previous example, it did generate the transaction. It was actually the non-AI agent part, the signing of the transaction, which failed. But as you can see, we've got the transaction receipt, we've got the transaction result. So what's happened here, just to reiterate, is the AI agent, which doesn't have its own private key this time, it's a human in the loop agent. It's a return bytes agent. The agent has used its tool to build a Hedera transaction, and then it's returned the transaction bytes so that I can then sign it on the client side. And in a real life example, it would be that maybe you've got your AI agent on a get endpoint and you are generating transaction bytes on the server side. And then the response that the server gives to the client, where the user is with his wallet, is going to be transaction bytes. You can then use Hedera Wallet Connect to actually sign those transaction bytes with your wallet. So that would be equivalent to what we're doing over here. So that's pretty cool. I mean, again, look at these codes, look at these examples, join the Hedera Discord and tag me, create sort of topics and discussions, and we can help you one-to-one. You can also create your own AI agent tools, and that's relatively trivial. I mean, you can do it. You can create your own custom tools, or as Lindsay mentioned earlier, you can also create issues in our Hedera AgentKit repo saying, I want this tool, and then we can help you do it. Let's now have a look at the AI SDK. So it's broadly going to be the same thing. Only difference is this time we're using the Vercel AI SDK framework rather than LangChain. But fundamentally, it's pretty similar. So with with Vercel AI SDK, similar to the LangChain SDK, you can easily choose different models. So I'm sure if we were to do something like Claude over here, well, maybe I need to install it separately. But here, for example, passing in OpenAI, but we could pass in any other available LLM, just like over in the LangChain side, we can easily pass in any other LLM over here. We could do a Claude AI instance rather than a ChatGPT AI instance. But very sort of similar interface, sort of using the relevant framework. You are creating your Hedera toolkit, and then we're just getting those tools and we're passing it into the agent, and then we can now start interacting with the AI agent over here. And like I mentioned earlier, I mean, we can probably do some more examples on sort of the full stack application side, but the Vercel AI SDK is very powerful when it comes to actually building full stack applications, because they've got loads of very easy to use hooks and functions which integrate very nicely with Vercel or with Svelte or with Vue or any other leading framework. But let's try this Vercel AI SDK. It's going to be pretty similar result to before. We're running the script. Let's do something like create a topic. Now this is going to be using the Hedera consensus service. Let's come back. No, I don't want either. Maybe this one doesn't have memory. Let's go create a topic with memo hello. Perfect. So it's created that. Now I'm going to assume the reason why it's responded over here like this is, it sounds like you might be referring to a previous suggestion. Actually, it probably doesn't have memory set up, which is an advantage for LangChain, because LangChain, they export these really easy to use memory classes. I'm pretty sure the AI SDK will have something similar, but in this case it doesn't. So it sounds like our demo over here is just sort of once you ask it once, you get a response once. It doesn't have that wider context. But as you can see, we've created this topic. I mean, if we go over to Hashscan again, we can see over here that there's a topic that's been created with the memo hello. We should be able to submit a message, assuming we have the submit message topic. And yeah, we've got the submit message tool. So let's go submit hello world to this topic. And it should know that I'm asking to use the submit message. There we go. Perfect. So we can head back over to our block explorer. And if we refresh, didn't even need to refresh. As you can see, hello world over here. It's just sent that message. So that's the SDKs. that's obviously the using the Hedera AgentKit SDK with frameworks such as LangChain and AI, Vercel AI SDK. But another way that you can use the Hedera AI AgentKit is by using creating an MCP server. So another one of the classes which the Hedera AgentKit exports is a Hedera MCP toolkit, and we've got our own example. MCP implementation in the root directory over here. All you need to do to sort of set it up is just go into the Model Context Protocol directory, install everything, and then you want to run npm run dev. Npm run build. This is going to build the MCP server, so you don't actually need to do it yourself at all. We've got some arguments which you can pass in when it comes to running it to sort of filter out particular tools. By default, it will do every single one of the tools. And over here, I mean, this is just sort of some boilerplate essentially. The main thing that you need to do to create it is pass in your configuration into the Hedera MCP toolkit. That then returns a server, and then all you need to do is just do this using existing model context SDK classes like this standard input output server transport. So I'm going to connect to this MCP server using Cursor, because if you didn't know, Cursor is an example of an MCP client. Another example of an MCP client, where an MCP client is an AI large language model or agent which connects to an MCP server. Claude is another example. So if you have the Anthropic Claude desktop application, you can also set up and connect it to MCP servers. Likewise, you can also use popular AI agent frameworks like Vercel, like LangChain, like the out-of-the-box OpenAI SDK. Basically everything you can also connect to an MCP server. So you can think of MCP servers as the standard way of taking an arbitrary AI agent and giving it access to a set of tools. And they both follow the same protocol, MCP, the Model Context Protocol. And it essentially allows any agent to connect with any MCP server. And over here, I've obviously set it up already, but you can have a quick look over here in terms of how you do it. So you just need to sort of add into your map of MCP servers in Cursor. It's exactly the same if you're using Claude. It's exactly the same if you're using any other MCP client. You specify the command that you want to use, pointing it towards the directory. I'm saying that I want the testnet for the ledger or the network, and I've passed in my own keys because I want this AI agent to be an autonomous agent. But equally, we could go operational mode. We could say operational modes return bytes, and what this would do is it would then be an agent which returns the bytes, like we saw in the LangChain just before. But let's remove that for the time being. So we've got our MCP server. As you can see, it's green. We've got 10 tools enabled. These are the tools that we have enabled. And now, if we go over to our chat, we can just say, "What's my balance?" Now, again, because MCP is a standardized way of connecting a client AI LLM agent to any arbitrary set of tools, we don't need to write anything technically. You can just take the MCP server, spin it up, and then connect to your MCP client. You don't need to write any code which runs a LangChain script. You don't need to write any code which does Vercel. It's as simple as spinning up the MCP server and then you connect it, and any amount of AI agents can connect to it as well. We can do things again over here like transfer 5H bar to this account, and it will identify which one to call. It will create the response. It will send that using the JSON RPC sort of messaging syntax, and voila, transfer of 5H bar has been successful. And what I quite like about MCP is that it really separates the concerns of the tools and the LLM. And what that means is that you sort of get this really nice inference layer where if I want to do something like create a token, because the LLM knows the schema that because the LLM knows the schema which is returned from the MCP server, it knows exactly what's required and what's not. So immediately it comes back saying, okay, you need to give me these information over here. And this is also possible using things like LangChain or Vercel, but it requires a bit of prompt engineering. Whereas because with MCP servers, you've got the LLM on the client side and the tools on the server side, and you're actually, the first connection that gets made is you have all of these tools, this is the syntax. It, in my experience, gives it a bit of a better understanding as to what tools they are, whereas when they're tightly coupled, that dynamic is not quite the same. That's just my anecdotal experience. But yeah, to summarize, we've shown how to run a LangChain agent using the LangChain SDK. Inside of our examples folder over here, we've got return bytes tools where you can specify, I want this AI agent not to execute anything. I don't want it to be autonomous. I want it to build a transaction, return the transaction bytes, which can then be signed on the client side by a user. We've done that. This is something, by the way, which is very unique to Hedera. I've not seen any other AI agent kits which have these dual operational modes where you can do return bytes and actually execute it using a wallet. And you can also run the autonomous mode. So we've got the return bytes. We also went through the autonomous execution mode, both for LangChain and for the Vercel AI SDK. And then we looked at the MCP server. How can you spin it up, get it running locally, and then how can you connect your MCP client like Cursor or Claude to it to then start interacting with Hedera just via a simple chat user interface. All of this is available on the current Hedera AgentKit SDK. Again, I'm going to repeat what Lindsay was saying. If you've got any questions or comments, ask us. You can ask us in the Discord, but you can also raise issues and start interacting with the GitHub. We want to make it a very collaborative, community-driven repository. So if you have ideas, do not hesitate to sort of dive right in. Oh, and actually another thing which I want to share, just while we have a bit more time, is what I think is a really cool feature that you can actually pass in a mirror node service. So the benefit of this is that when you're doing queries, obviously we're not querying the network directly because that costs a fee. We're using the mirror nodes, the REST APIs to do that. But the default mirror node REST API has throttles. It's not really meant for production use. If you want to have an application which has got lots and lots of throughput, maybe you're doing hundreds of requests per second or per minute, you don't really want to be using the public mirror node. You probably want to be using a paid service. And obviously, in order to use that paid service, well, if we didn't have this mirror node injection, a dependency injection feature, you kind of be limited where actually you couldn't really use this SDK. But what you can do is you can create your own mirror node service. You can pass it into the context, and you can see an example mirror node service implementation in our source code over here in shared Hedera utils mirror node. You can see the default implementation, which uses just the basic public mirror node. But as long as you create your own service which implements this Hedera mirror node service interface, you will be able to create your own mirror node service with hgraph or with Dragonglass or with whatever provider that you want to use. And you can actually use that inside of the AI agent. It can have your own private keys, it can have your own API keys, anything that you need, you can bring it along and start using your existing mirror node provider in our AgentKit, which I think is a very important point to be sharing. Because that would be a blocker for a lot of people, quite frankly, especially production sort of applications. And we're going to be extending this interface over here. I would love it if we have people from the community like hgraph, etc., who want to help us build some more mirror node services, like a hgraph mirror node service, etc. And yeah, it'd be great if you could have community contributions for that as well. So that's it on my side. I know we covered a lot. I guess final thing, just definitely hit us back up on Discord and interact with the GitHub. That would be very helpful. I'd love to see more community contribution in that aspect of that. I'm always happy to help when it comes to actually building this sort of stuff too.
Okay, thank you so much, Lindsay, for the wonderful sharing, and for Jake for that very helpful demonstration Tokenization. Yeah. So obviously we discussed heavily about the Hedera AgentKit. Of course, it's a toolkit or a framework designed to help developers build AI agents or applications that interact directly with Hedera network using APIs. Yeah, very helpful. So for everyone who wants to ask questions, you can ask questions now so that our mentors can answer you live as well if you want to. Right. Okay, so we have one question here actually. With the introduction of direct API calling tool, does this mean the AI agent can now handle API interactions autonomously, reducing or eliminating the need for manual setup or execution of API calls?
Yes. Yeah. Um, yeah. I think if either you build your own tool which does the API call, or you tap into an existing tool which exposes the API calls in tools which you can ready to use. But definitely, when you can, if you have an AI agent using tools, you can definitely interact with APIs, and it will automatically execute it.
Okay, great. Thanks so much for that, Jake. Let me just see if we have more questions here. Okay, I think that our audience are still digesting what they have learned from the workshop, right? Yes. So maybe we can all regroup tomorrow during the AMA session to answer your questions. And you can have definitely an interactive moment with your mentor. So there could be a one on one session. We have a good space tomorrow, all prepared for the developers, so that you can have that space to talk to your mentors. And of course, once again, you can talk to them on Discord. So please join this hackathon on the on the screen. Please scan that QR code, and then you can definitely start hacking, and you can start. Yeah, it's somewhere there, wherever it is on your screen. Yep.
Yeah,
Reset.
I want to say we're really excited to get some feedback from the community to help us really set the direction of what we're going to be doing with this. I see there's one, but yeah, please go to Discord, ask questions. There's our GitHub repo. I highly encourage you to open issues. This is a really good way for us to keep track of, hey, what do people want? What do people need? We already had a really great request for, hey, is it available for Python? Well, there's a request out there. That means it's a lot more likely we're going to start creating that. Very shortly, we'll have sort of like a feature request GitHub issue or GitHub issue form. And that's a really great way of making sure that it gets on our roadmap and gets right in front of us. So please request features, ask questions. It helps us understand how to make it better for you.
Yeah, of course. Thanks for that, Lindsay. Okay, so yes, please join and scan this QR code right now while it's still presented on the screen. And hopefully you can give it some feedback. That's very, very helpful so that we can build the future all together. Yep. So I guess let me just share this on the screen. Yep. So once again, tomorrow, 24th of July, 10 a.m. Eastern Time, you can scan this EMA form. This is a QR code, and you can scan that. And with that, you can put on all your questions, and then we will address it by tomorrow. And on this middle QR code, that's our AMA space. It's very, very nice. You can start already, and then you can start checking what this space is about. So it's a very gamified space. Everyone is welcome to explore it. Yep, and that is where we're going to hold our AMA tomorrow. Then, lastly, on this side, the calendar for our hackathon, there's also the website so that you can follow our upcoming events or upcoming AMA sessions and workshops. So, that is very helpful for you. It will convert to your own time zone. Yep. Okay, please scan this. Jake, let's say, would you want to have any other sharing before we end the session, I guess?
No. I think please really take every opportunity that you can to ask us questions, ask other mentors questions, because we are really here to help you not just build a good hackathon submission, but a really good product that actually can live on after hackathons. That's our objective at Hashcraft.
Exactly. Yes. Lindsay?
I think yeah, just like I said, please don't be shy to ask questions, give feature requests and clarifications, because nothing's perfect and we want to make it better for everybody. So the more questions and feedback we get, the better we can add to and improve what we're building.
Yeah, great, great. Okay, so thank you everyone for joining this meaningful workshop. Please keep pushing boundaries and build a future with Hedera. Wishing you the best on your hackathon journey. Good luck. Have a great day or good evening. And goodbye for now, everyone.
Bye.
The need for a more interconnected world is fueling new decentralized technologies and new ways of doing business. Hedera stands at the forefront of distributed ledgers, where every interaction is not only trusted, but fast, efficient, and secure. While traditional blockchains struggle with speed and fees, Hedera's network settles transactions in under 3 seconds for a fraction of a penny. And the proof is in the numbers. Hedera is uniquely governed by a council of the world's leading institutions, ensuring transparency, trust, and decentralization. It's no wonder Hedera is the leading choice for enterprise and DeFi use cases. Everything from real-world asset tokenization to AI data integrity. Discover the only decentralized network with the governance, scalability, and security to power the new digital economy. What future will you build?